Thanks for having me. 안녕하세요. Yeah. How is everyone doing today? Are you still awake? Okay. So today I'm going to talk about Frida. So let me first introduce my team, my brilliant students and wonderful faculty collaborators who's making things all possible. And in my team, we work on the intersection between AI and robotics. So as you all know, there has been breakthroughs in AI space. And we believe robotics is the way to bring those breakthroughs into the real world through robotics. Okay. So I'm going to show a lot of different applications. At the surface level, they all look different. But I basically do two things. So one thing is I want to make the robot to work with humans, so coordinate with humans. And I'd like to use human language, natural language, for the robots. I've worked with the robots on the ground surface and also the aviation and underground. And to complete my profile, I only need underwater and space. So there's a lot of applications in this domain, but I basically want to use language to command the robot to do things that we want. And using language just lowers the bar for the usability. So anyone, even children, can use robots easily. And when we use the robots, the big difference between just a language model is including perception. So how to interpret vision and language understanding together to take actions. Because actions are the only things that can make changes in the real world. Okay. And now I'm moving to the art, and many people ask this question, why? Why art suddenly? So let me explain why. Okay? So there are two main reasons. And the first one is, let me first ask this question. Who likes math? Come on, math is the most beautiful subject in the world. So it's a purest form, and we can study very, very complex problems in math in a very pure form. And just like math, art is beautiful. Art is like math. So do you know this quote? It's a famous quote. Just kidding. So I wrote this, math is like art. Okay. Art is like math, likewise. So that makes us to do a lot of difficult technical challenges in a fun way. So after starting painting and sculpting in my group, I was able to work on a variety of different core challenges in robotics, and more people come to us to work with us. So I wish I have time to go over all of these, but these are all, each of them is a specific field in robotics, and there are many people are working on each of these sections. And today I'm going to focus on two of these things, and one more thing at the end. So one is how to reduce the gap between simulation and reality. Okay. And then the last one is rather important, and it's growing. Because we are generating contents and we are making changes in the real world, we want to be responsible. We want to make the AI and robots be responsible for what they're doing. So this is going to be an important topic to think about. Okay. And then the second part is more broader purpose of using art. And that is to create real-world human values. What does that even mean? Okay. So I'm going to give you some examples. So the first of all, real-world art is different from digital world. So you have seen OpenAI's DALL-E 2 and also Midjourney. Who's using these tools? Like, have you all tried? So these are amazing. It works great, but they live in virtual world. So we want to bring that great things into the real world using robotics again. So these images generated by DALL-E or Midjourney, you can print them. You can just send it to the printer and then get a copy. But it cannot be painted, because painting requires planning and taking each brush stroke at a time. And then the second thing is, this is my personal thing. I'm an old generation, so I don't want to see children just looking at iPad all the time, playing computer games. I want children to mess with paint and also work with the sand, play with the Play-Dohs, and interact with the real people. So we need some way to bring this next generation, future generations, back to the real world. Like in order to live and really situated in the real world. And then the second part is the self-expression. So art is just a powerful way to express our ideas. And when I say art, I'm not talking about the things that you can only see when you go to museums. I mean, they are also great art, greatest art you can find and you can appreciate at the museum. But art is just a way of communication. And think about children drawing. It's just always giving this awe, which is kind of an emotion that kind of touches your inner side. Art should be everywhere. That's what we really want to promote. So, and this is a great way to express. So some of these paintings are here, and this kind of carries on what I care about. So we did a lot of paintings last year about the war, and you see the colors of Ukraine in the paintings, and also about women's rights. And these are the things that I care, but I'm not really a painter, but now that I have Frida to work with, I can create paintings to express my ideas, what I feel. So this list goes on and on and on. It just has so much human value. Okay, and then I'm gonna just play this cute video. This is my favorite part. So,
what you doing? Painting.
Yeah. It's just.
No, the painting robot, my favorite. Can the painting robot paint me a picture?
Of course. So this is Zach Manchester, another faculty member's son. He has all these cool NASA space robots, but his son loves our painting robot. Okay. And whenever I had a cool robot demo, everyone likes robots. Any kind of robot demo brings people crowd. But with the Frida, I see kind of little bit different appreciation from people. So that's the part that I'd like to study a little more, like what people actually feel when they interact with Frida and see the artifacts. And this is, so the French children's magazine, and we made a cover page, and our names weren't even mentioned, but this is my favorite among all the media coverage that we have seen. I mean, this indicates that our work really reaches out to little children. So that was a very long introduction and background information. So I'm going to tell you a little more about how Frida system works, just a little bit. So I'll give you 3 seconds to think about what you want to paint with Frida. So, 3. Okay, so you all have ideas, okay? Right. So how would you pass that idea to Frida? So how do we describe what we want? It's difficult, right? So communication is always difficult, but we have language. And language is not perfect. It has a lot of ambiguity, people misunderstand, lots of noise, mess. But that's what we use, and we are used to using it. So we will continue using it, supporting it. And then sometimes we use quick drawing. So whenever you have a conversation, you kind of draw something. So that's another way. And then when things are very complicated, like the pattern in the ceiling, I just pointed, like, I want something like that. So give an example, okay? So those are kind of quick ways to communicate ideas with another agent, either human or robot. So in the Frida system, we want to support all these different modalities to communicate with people. Okay? So recently we started using sound. So I'm super excited to have another PhD student starting his thesis on the topic. And whenever I say semantic goals, semantic means something that's meaningful to people, like something that has names, like we named something. Okay? So that's how Frida system works at a higher level. And then I'm going to kind of repeat the same thing using a different example. So semantic planning is given this high-level goal. Someone has to come up with a plan, which is a sequence of actual actions you can take. Okay? So navigation is a great example. So in this example, I'd say to the robot, like imagine you're that tiny robot on the corner. Navigate to the building behind the car. And you don't even know where you are, but you can just imagine some space and then come up with something called an initial plan. And how do we do this? It's so easy for us because we have seen a lot of similar examples, right? So we want to do the same for the robots, but when you're situated in a particular specific environment, we need to customize the plan and revise our plans. And we can just do it because the initial plan is not that different from the new plan. And for the parts that we still cannot see, you can still use the same idea. You imagine the space, hypothesize what might happen, and then just keep doing it. Keep replanning as you collect more information about the real world. Okay. And then just use the same idea for painting. So I used the BTS is dancing as an example. And you already visualize that image, right? So that's the process that's happening inside like Frida system. So you imagine some image, okay, but this is only inside your head. Can you paint this? Then you need to take actions, so it goes into the planning stage. And the difference between navigation and painting is the action space. So whereas the action space in navigation is taking steps, like how to move, and in painting, brush strokes. So to me, the two problems look very similar. And I hope you now agree with me. Okay, so I'm going to go into a little technical part of how we reduce the gap between simulation and real world. Okay, and that's again, I forgot to mention Peter, a brilliant PhD student working on his thesis on this topic, and Jim McCann, a wonderful collaborator. And in the Frida system, what Peter is focusing on is how to reduce this gap between simulation, what you imagine and what you can actually do. And we also face that challenge too. You can imagine yourself doing all kinds of things. But when you actually want to execute a plan, you realize that there is a gap, okay? So it's difficult. And you might want to borrow the idea from Frida to apply to our own problems too. So the little bit of a past work. So we started like back in 2019, and when we first tried using some existing planning algorithm, and we used a very, very low-end, like $200 Amazon purchase robot, and the quality of the painting was very poor. It was almost funny. And our first approach was, let's reduce the gap, because the robot is not very capable. So can we generate the strokes that this tiny robot can actually paint? So we add handcrafted constraints to make the gap a little bit smaller. And the result was much better, so you can visually see. But the gap was still large. Okay? And then the next thing that we tried was using the real data. So let's have the robot to show us what they are capable of. So the robot kind of shows random brush strokes, maybe 200, 300 strokes, and then we collect the data and then train the simulator using those real data. So that's called the real to sim to real. So that makes sense, right? So this way, the plans or images generated by the simulator really matches with the real robot's painting. So it's a very high fidelity simulator for that, really customized for that particular robot. So we can use this idea for our planning. We need to understand what we can do, and then we plan the feasible ones. Okay. All right. So the result was, okay, this was the earlier one, and then the second one was the handcrafted ones, and the third one was substantially better. So we got to do a lot more painting using this idea, and then more. So I'm going to stop on the painting part for now. We are continuing this work, so we will maybe talk more and show some kind of preview of what we are doing at the end of this talk. Okay. And then the second part is the fairness issue. So this is led by my master's students and also collaboration with Professor Ji-hee Kim at Dongguk University across the street from here. Okay. So why do we even care? Because there are two major reasons. Because diversity matters. And there is a scientific proof, and also AI knows diversity matters. So, or any type of machine learning or AI, essentially they're doing one thing. We want to find the best possible solution. And it's kind of a searching through gigantic space. And if you just work with people you know, your neighbors, people who look like you, then you get trapped something called local optima. And in Korean, there is an expression, 우물안 개구리. Yeah? So to avoid this local optima, we need to include more people. You need to diversify your team to reach and accomplish higher goals. And then the second thing, representation matters. So for this one, let me show you some examples. So maybe you can feel what this means. Okay. So question. So among these pictures, can you recognize which one's American? It's hard, right? So I'll give you a hint. Half of them are just generic. So the prompt was just generic. Woman is painting, and family is eating together, photo of a house. And the other half was customized for America, just United States. Still very hard, right? I can't even tell. Okay, so that's the truth. So these images were generated by one of the state-of-the-art text-to-image generator. And even if you have been using them, you probably haven't realized that there exists bias. Okay? So what about Korea? How are we represented in this space? Okay? So these are the images generated by Stable Diffusion. Okay. So I'll leave it up to you how you kind of assess the quality of the images. And like this is traditional Korean custom, but questionable. And then this, I don't want to show this to the fans, okay? But so this is how we are represented in this large model space. Okay. So representation matters, right? So we kind of understand the problem. And to tackle this problem, we need to first understand why this is happening. Okay? So the truth is, this particular model called the stable diffusion was trained on a data set called Lion. So Lion is the intent was great. So a lot of great big companies, they own the data, and all these like super performing large models were trained using really, really large data sets that they didn't release to public. So this group came up with an idea, okay, let's make a public data set that all the researchers can work on. So their intention was great, but because it's very expensive to create large data sets, they had to automate this process. So this is automatically collected and unfiltered. So they acknowledge there will be issues. And we also see these issues. So how do we tackle this? Okay? We cannot collect 6 billion text-to-image data and then label them properly. Okay? So quickly, what we try is using something called the priming. So priming is a concept used in human psychology. And when people have bias, it's very hard to shift your distribution inside very quickly. It doesn't happen that way. Like, I'm a woman, I'm an Asian, but I still carry the exact same bias when I'm sitting on the other side of the table. That's the bias. So knowing that there exists a bias doesn't fix it. And even if you are part of the discriminated group, you still carry the same kind of bias. Okay? So it's tough. But priming is one of the few methods that kind of was effective in fixing implicit bias quickly. So the idea is showing a few very positive examples right before the test. Then people suddenly kind of shift. So our technical idea is not exactly the same, but conceptually, that is the idea. We use very, very small amount of high quality data to refine the model. Okay? And luckily, I have students from 9 different countries. So we covered 9 places on the world map, and our goal is to put the dot everywhere, to include everyone in this like large models. Okay, so some qualitative examples. So Nigeria, whenever we ask about Nigeria, the country is just portrayed as such a poor country and people are starving kind of a situation. And now with our approach, it's generating more modernized Nigeria. Same thing for the houses, we can generate better images. So overall, the results, we are very happy with what we see, and they look great to us. But it's a science. Like, in order to convince other people, we need quantitative result, which means numbers, like metrics. But evaluating something like this, cultural relevance or social compliance, things like that is super difficult. So that leads to the last part of the talk. So the evaluation challenge. Okay. So let me start with the quote from Galileo Galilei. So measure what is measurable and make measurable what is not so. And what we are trying to do is this second part, make measurable what is not so, which is super difficult. Okay, so let's see. So again, I'm going to kind of show you 2 different examples here. So first one, before we start, does everyone know what Turing test is? Yes? Okay, so Turing test is set up. You have kind of some agent performing some task behind the curtain, and then ask people, hey, do you think the other person who's doing the job is a human or not? And then if they pass the test, and they say they passed the AI system passed the Turing test, that means the AI system is as good as humans in that particular task. So it was a popular concept, and it was proposed in 1950. Like, I don't think you were even born, a lot of you, right? So this is a very, very old idea that's still around, okay? So my argument is kind of provocative thing, but based on the experiments that I kind of have done, Turing test doesn't reveal much anymore. So I'm going to tell you why. Okay. So the first experiment is on AI pilot, meaning we have a pilot that's kind of all fully automated, just like self-driving car. There is an area vehicle that is fully autonomous. So the Turing-like test-like setting. So I mentioned this as a Turing test-like setting because we ask a lot more questions than do you think it's a human? Okay, so it's a similar setup, but we include a lot more questions. Okay, so in this setting, on one side we recruit pilots, and then the pilot is flying in simulation. And then on the other side, there's always a human pilot sitting, but sometimes the pilot doesn't do anything. It's just the same setting. It's all AI, or sometimes it's the human pilot actually flying. Okay, so the result from this study was, it was interesting. So we had 26 FAA certified real pilots came in, and then like assess the other pilots' performance based on many different criteria, just like performance review. As the AI part becomes more and more complex, it is not very different from evaluating human performance. So that's why it becomes much more complicated. So, and the good, the big takeaway here is it's very similar to what people found from self-driving industry too. So initially, people thought that if autonomous vehicle can explain what they're doing, maybe people will be happier. But that wasn't the case. People only trust and also accept autonomous systems when they perform really, really well. So competence is the key. It's kind of same as the human world. So we like nice people, but if nice people don't perform very well, it's not, the person is not going to stay for a long time because the job requires competence. So that kind of makes sense, and it is very consistent with the human world. Okay, and then for the Turing test, we found an interesting finding, which we expected, and the answers are kind of a 50-50 split. So people say it must be a human because they are awesome. The other half said they must be human. They changed lane like when they were not supposed to. They violated the rules. They went too fast. Their path looked ugly, whatever reason. So they're really bad, so must be human. So this is kind of an interesting observation, and also it indicates people's understanding of an AI system has also evolved. Like before, like in 1950s, like if you pass as a human, that was a great thing. But now, people actually believe that for some certain things, AI may be doing a better job, like following guidelines. Maybe AI, since it's an AI, like naive system, maybe they never violate rules, things like that. So people's expectation has evolved. So asking the Turing question doesn't really give us any insights when we develop technologies. So, okay. Okay. And then we had an opportunity to participate in this kind of fun experiment. So it was similar to the other Turing test. So again, it was Turing test-like setting with the museum audience. So, and Frida painting, one of the Frida painting, and the same, there was a person who was sitting as a model, and then there were 3 human painters doing the same painting, and then audience actually got to vote. So I'm going to play the clip. So this was part of a documentary done by Australian Broadcasting Corporation. And on the actual shooting day, my flight got canceled, so I only showed up briefly. But this was really fun. And then at the museum, people were really taking a long time to make their decisions. It wasn't like, oh, obvious. And one side, there were painting contests, and on the other one, there was a photography, AI-generated photography and human photographers' work. And that one was super difficult because it was a digital space. So, okay. So on this one, the result, overall, Frida, got more votes as an AI system, but the interesting result was more than half of people voted some other human painters as an AI. So in a way, it is kind of, we can say, maybe Frida passed the Turing test. So this was an interesting experiment. This measuring creativity, social compliance, and other things, these are just so difficult. So what do you do when you have a question and it's just bothering you and you just don't have clear answer? Then you just gather people around, like smarter people, and ask and have a discussion. So that's what I have been doing. So events like this is a great opportunity for people to discuss open-ended questions. Because sometimes, a lot of discussion leads us to nice answers. So I've been organizing a lot of workshops to discuss what creativity means, and also how we can measure, what's the metric? How can we put the numbers on this creativity space or the quality of the art, and so on. And after a series of these workshops, I was more confused, but I summarized the discussions into 4 different categories. Actually, 2 of them are very, very subjective, so it was a very noisy space. But there are 2 actually quite interesting directions that maybe will lead us to the right way. One is the context. So context means people want to evaluate anything that's given within existing context. They want to compare with what they have seen so far, what has been built so far. So that's great, because that's what we do in AI and machine learning. We always find patterns and compare and detect anomaly, what's the distance from the distribution, and so on. So on this direction, it's very promising. There are even some metrics that we can start using for evaluating creativity or novelty, other things. And the other one is a human values. So getting back to the original question, what is a human value? And human values are the most vague and also very difficult ones to measure, right? But think about it. Among these human values, there's one thing that's in numbers, and we use it every day. Can you guess what that is? I know there are a lot of people from finance, money. So anything that can turn into profit is a measurable because it's number. So, but there are greater human values that are priceless. Of course, there are things that we can never put a price tag. But think about a lot of things that we use in the normal, like daily lives. Everything has a price tag, and we are very good at giving quotes, even for new things. So this may be a way to kind of have a metric or some ways to evaluate our progress. Because we need this as a researcher. Without the guideline, like it's very hard to make progress if you don't have numbers in this space. Okay, so on this space, if you have any good ideas, please come talk to me, how to evaluate human values and human value related topics. Okay, and again, this is the most open-ended question that we are facing. So the two that I just discussed is just ideas. So it's not like a definite answer or proposal, but something to consider and think about. Okay, so what's next? So the Frida painting was in 2D. So now we are working on the 3D side. So 3D means sculpting. So going into 3D, we are really getting to the most difficult part in robotics, which is deformable object manipulation and general manipulation. So manipulation has been very slow and super difficult, and even the planning space, because it had multiple joints, arm, fingers, and things, it's a high-dimensional space, so much more complex to plan, and efficiency is hard to achieve. So very difficult, but by just turning that into sculpting, everyone is having fun. So we now have a lot more students trying to join my group, and then also a lot more faculty members reach out to me to collaborate. So this has been amazing. And then the second part is the Frida. The original Frida was meant to help people to express ideas, but it was still kind of a one-shot. So I tell Frida, okay, I want to paint about war in Ukraine. That's it, like one shot. And now we want to make it really, really interactive system, going into the true collaboration. So, and it turned out that supporting that is super difficult. Like we initially thought that, oh, what can be so difficult? The difficult part is taking into somebody else's ideas into generation. Because now there are two agents trying to maybe going for the same goal, but the strokes, the actions are different. So it's like you've been working alone to achieve some goal, and you have an assistant who's messing things up. So adding more strokes that it's different from what I initially planned. So how to incorporate, coordinate those actions into the same goal turned out to be difficult. So we are currently working on that collaborative Frida, co-Frida, and we have some pretty good results already. So you will see the next version of Frida soon.